All right, we are going to be dividing monomials. We have completed adding, subtracting, and multiplying, and that just leaves dividing. When dividing monomials, the most important thing that you have to do is to, first of all, determine where the variable is going to go in your answer. The largest degree determines where it goes. If the largest degree is on top, like in the example x to the fifth over x squared, that means that your variable x is going to go on top. And on top means above that fraction bar. Okay, we then have to do something with the exponents, but this simply means that x is going to be on top. When the largest degree of the variable is on the bottom, that means that variable is going to go on the bottom. So in the next example, I have x to the 6th divided by x to the 8th. The largest degree is on the bottom. This tells me in my answer that x is going to be on the bottom. So when you are dividing monomials, we have to know what to do with those exponents. We look, first of all, to see where the largest degree is, and then we subtract the exponents. You will never, ever, ever have a negative exponent. If you have a negative exponent, that means that you've done that subtraction wrong and put it in the wrong location. So an example that we have, b to the 5th divided by b squared. I look at this and I ask, where is the largest degree of b? The largest degree of b is on top. So that means that b is going to go on top. And I'm just going to write it above there, that fraction bar. What do I do with those exponents? I subtract. And I'm going to take the exponent on top because it's larger, minus the exponent on the bottom, and that's going to give me b to the 3rd power. This is like if we had b to the 5th would be b times b times b times b, 5 b's multiplied together, divided by 2 b's, and I would cancel anything in common. I have b's top and bottom. I have another b top and bottom. And now I have 3 b's, and they're only on top, and nothing's left on the bottom, so that would be b to the 3rd power. But instead of having to do this for every problem, we have the rule that says, ask where is the largest degree of the variable, and then subtract the exponents. All right, on this one, I have x to the 4th divided by x to the 6th power. I ask, where is the largest degree of x? The answer is on the bottom. If the answer is on the bottom, that means that I'm going to have a fraction bar, and I'm going to put x on the bottom. I'm then going to subtract those exponents. So x on the bottom exponent minus the top, and that's going to give me x to the 2nd power on the bottom. But there's nothing left on top. If I have something in the bottom of a fraction, I have to have a top part to that fraction. So what would that be? How do I get what goes on top? Well, these variables have no numbers in front, but I know this is understood to be a 1, and this is understood to be a 1, and we know 1 divided by 1 is 1. Therefore, the placeholder for that numerator is going to be 1. All right, simplifying this division problem, I have m's on top and bottom, and I have n's on top and bottom. So I'm going to look at my m's. I have m to the 7th on top and m to the 1st on the bottom. And I ask, where is the largest degree of m? And it is on top. And then I subtract. So since m is on top, I put the exponent on top minus the exponent on the bottom. I then look at my n's. I have n to the 5th on top and n to the 2nd on the bottom. I ask where is the largest degree of n, and that is going to be on top, and I subtract top exponent minus bottom exponent. So that means that we have nothing in the bottom of this fraction. I'm then going to simplify. On the m, I have 7 minus 1, which is 6. And on the n, I have 5 minus 2, which is 3. A lot of times we will find dividing monomials easier than multiplying. All right, our next example, we have x cubed y to the 7th over x to the 5th y to the 4th power. To simplify this, since I have x's top and bottom, I ask where is the largest degree of x, and it is going to be on the bottom, which means I have to draw a fraction bar. I'm going to put x on the bottom, and I'm going to subtract bottom exponent minus top. Always have the biggest exponent there. Then I look at my y's. I have a y on top and a y on the bottom. The largest degree of y is on top, therefore y is going to go on top, and I subtract largest degree minus smallest degree and simplify to get y to the 3rd over x to the 2nd power. All right, this one we've added numbers into it. And guys, numbers are numbers. Anytime that I see 81 over 9, I know that means division. And that's what we're going to do to that particular part of the problem. Numbers are going to be divided. So when I do 89 divided by 9 on Desmos, it is equal to 9, which means that that would be on top because that's an integer. I'll look at my variable a. I have 8 to the 8th on top and 8 to the 5th on the bottom. Largest degree of a is on top, and I would subtract 8 minus 5. I have b's top and bottom. My exponents are 3 and 1. Largest degree of b is on top, and I'm going to subtract. And then simplify. I have 9a, 8 minus 5 is 3. On the b, 3 minus 1 is 2. So my answer would be 9a to the 3rd b squared. So in dividing monomials, if you have numbers, that is division. And that's the operation that you would have to do. All right, on this particular problem, we have numbers. We have 3 divided by 3. We know 3 divided by 3 is 1. But look at my m's. I have m to the 3rd divided by m to the 3rd. We ask the question, where is the largest degree of m? Well, there's not one. They're the same. When those degrees are the same, then these are going to cancel, because we know anything divided by itself is 1. So at any point in time, if you have the exact same exponents, top and bottom, that means those variables are going to cancel and you are not going to have anything left. Then on the ends, we have n to the 3rd on top, n to the 2nd on the bottom. Largest degree of n is on top, so n goes on top, and we subtract. And when I subtract, I get 1 n to the 1st power. Now, this is not normally how you're going to see this on an SOL test. That 1 in front is not going to be there. That 1st power is not going to be there. This would show up to just be n. All right, first thing I'm going to do on this example is I'm going to do 64 divided by 16, and that is equal to 4. I notice that there are g's on top and bottom. The largest degree of g is on the bottom, which means that I'm going to put g on the bottom, and I have to do the fraction bar. I'm going to subtract the exponents, 3 minus 2. Largest degree of h is on top, so h is going to end up on top, and I subtract 7 minus 5. I then simplify. That's going to give me on the h, 7 minus 5 is 2. On the g, 3 minus 2 is 1. So my answer is going to be 4h to the second over g to the first power. All right, on this problem, I have numbers. I'm going to type into Desmos 3 divided by 18, and it could possibly give me a decimal, but I want this to be a fraction, and that is the fraction 1 over 6. So that means that my answer is going to have a fraction bar because the numbers gave me a fraction. I'll look at the variable r. I have r to the fourth on top and r to the third on the bottom. Largest degree of r is on top, so r goes on top, and I subtract the exponents. I'll look at my s's. I have s squared on top and s to the fourth on the bottom. Largest degree of s is on the bottom, therefore s goes on the bottom, and I subtract. Then I simplify. I have 1 over 6, r to the 4 minus 3 power, which is going to be 1, s to the 4 minus 2 power, which is going to be 2.